Mr. MJ Keith, senior consultant at Denham Group, 10 years of experience in the network and information security field. Who came last year? Okay, so you remember this guy, right? Awesome presentation. Thank you very much. He's a great guy. He's been kind of adopted by HouSecCon as our resident researcher. He popped a 0-day for last year for Android, made like international press. Like we were #1 on Slashdot that night. It was just crazy. So I owe him a lot because we got people wanting to present here because we got so much press and it became a big thing on our first year. So thank you very much. He serves as a team lead on all infrastructure, security testing, and security policy analysis. He works with clients to implement security lifecycle activities. Y'all know MJ. You know, I don't want to go through all that stuff. But he has been quoted in SC Magazine and Computer World. And he's spoken at regional security conferences such as HouSecCon and B-Sides in Austin as well. So he's going to be doing Keynote, and then later on he's going to be doing a technical presentation on this. So without further ado, Mr. MJ Keith.
All right. First, I want to thank Michael and everybody that helped put the con together and inviting me to do the Keynote. Usually technical guys don't get to do Keynote, so it's kind of cool. And also, everybody for showing up, all the sponsors. I think these type of smaller conferences are kind of getting more important because everybody's security budget's kind of getting tighter. Not everybody can make it to DEF CON and Black Hat every year, so thanks everybody. What I'm going to be talking about is just kind of clouds and SaaS stuff because it's the new thing. It's what everybody wants to talk about. Everybody's trying to develop products for. This is just like kind of my opinion on the thing. I've seen tons of them, tons of cloud talks, and as you know, I don't necessarily always agree with what people are saying in those talks, so I just want to put my own spin on it. First thing, this is just a pet peeve of mine. If you're not a South Park fan, just replace the word Marklar with Smurf, and you should get it. People overuse the word cloud. It's every time you look around, there's a new cloud service. Now, I think a lot of us would kind of disagree. Whoops, I kind of covered that up. I think a lot of us agree that a lot of the stuff they're trying to call cloud now isn't even remotely cloud. I think cloud gaming was probably the most ridiculous one I've heard, but they just keep coming. Oops, wrong direction. Okay, so whenever you're going to talk about cloud stuff, you kind of have to be specific because there's so many different things we label that that, you know, if I start talking about cloud stuff, you wouldn't know where I was going. So these are the main types of cloud stuff we're going to be discussing. And also resellers are becoming really big, and that's actually opens up like a whole new layer of security problems. That stuff I'll be kind of going through deeper in the technical talk. So when you use those different types of services, what kind of information are you exposing? And I don't necessarily mean what's actually getting out there, what's being abused, but what are you putting in a position that could potentially be taken advantage of? For some of the services like Google Maps, like if you want to put a Google map on your site, you're not really handing off a ton of specific data. You're just going to be giving out things like longitude, latitude, possibly whatever information's on your site that Google can tie into that. But you know, Google has probably the most knowledge out of all companies. They know everything we search for. They know what restaurants get looked up the most, all this stuff. And when they can tie that back in with the longitude, latitude data, that gives them more information about it. And they all kind of vary as far as like the type of cloud you're using and the exposure that comes along with it. Things like, you know, file storage, well, you're giving up the files. You're putting them in a place where you don't necessarily have direct control. Things more like, you know, Salesforce or software as a service. In the CRM specific Salesforce, you're going to be giving up your client information, like who your customers are. communication, sometimes content. And then if you're using like EC2, that's going to be pretty much everything. I've seen a lot of security talks about the cloud. I'm still not sure what's so specific about the cloud. Like, why are you just now vulnerable because you're in the cloud? You know, you can set up a host-based IDS. You can set up a host-based firewall. There are protections there. And I think the reason is because it's the new thing. You know, voice over IP. I remember early 2000, I used to just be able to scan along port 23 and, you know, just get into hundreds of Polycom systems. They would actually pop up, had a really cool little banner. It would say, this is my IP and this is what I know about it myself. And then it would say, you know, you're now logged in as administrator. What do you want to do? And, you know, that's something that's been cleaned up. We now understand how voice over IP can be abused. Smart meters are another big one. SCADA is nothing new, but it's kind of made a huge comeback lately. So every new technology gets beat up. You know, I don't know how you hacked phone lines with serial boxes. Maybe there was somebody older that can explain that. And yeah, luckily, ping of death no longer happens. I think it's more appropriate to say immature rather than insecure. But if nobody really tries to move forward with it, then it stays in that state. It doesn't gain any. And yes, I look a lot like the dude. That was my Halloween costume last year. But I don't really think it's that bad. You know, I mean, if you've tried using cloud services, sure there's vulnerabilities, but more than likely there's vulnerabilities if you're hosted in a local data center. And it's the same kind of vulnerabilities. But there are a couple things you want to just kind of know before you decide one way or the other if the cloud's right for your business, if you want to support it, if you want to try to knock it down. One of the first things that kind of comes to mind is the Patriot Act and just other US laws and other countries' laws. Basically, if the government wants your data, they're going to get it. There's you know, different legal steps depending on what type of data they're after. For example, if an email is hosted on Gmail and it's 180 days old, they don't even need a warrant. They can just go in and take it. Now, Google tries a lot harder than most places to protect their customers and at minimum kind of notify them if something or if the government's requesting their data. But this has been happening quite a bit lately, especially around the Jacob Applebaum WikiLeaks stuff. Twitter tried to fight it, lost. I think Google and his local ISP are still kind of battling over it. And if something's hosted in the cloud and the government decides to seize it, are you going to be notified? Well, not if it's a national security letter. This is actually pretty old. It's not something they just came out with the Patriot Act, but it's being used more and more. And the kick with that is that the national security letter also comes with like an onboard gag order. That this prevents you from even telling anyone that you've received this letter. Doe versus Ashcroft was the, I guess, kind of biggest case involving this. It's actually listed as Doe versus Ashcroft for that reason, because they couldn't even use their name in the lawsuit. And basically what happened there is initially the judicial system sided with Doe, the ISP. It got appealed to a higher court, got kicked back down, and by the time they looked at it again, they said there's no point in continuing here because the laws have already changed, the Patriot Act has gotten stronger, so they just kind of threw it out. There hasn't really been any other challenges to these national security letters since then, or at least not that we know about. If your data is stored outside of the US and it's a US company, for example, Microsoft, Amazon, they're still going to hand your data over. This is, even if you're not a US citizen, your data is not stored on US soil, they're still going to hand it over. Microsoft, I think, got the most slack for this because they kind of were questioned publicly on it and responded. But honestly, Amazon, Rackspace, any other cloud service that's hosted or that's kind of centered in the United States, they're all subject to this. Now, if you look at other countries and not U.S. companies, kind of depends on the country's laws and that company that you're dealing with. They may want to be all friendly with the United States, they may not. And if you've ever looked through some of the WikiLeaks cables, you've probably seen that they make a lot of strange deals to get information, get gold, actually, in one of the cases. If it's somewhere like Holland, Holland really does not like our privacy rules. They do not allow certain sectors of their infrastructure and business to even use U.S. cloud services, and it's because they don't trust it. They think that we make it way too easy for the government to pull data about you. A couple other countries, Canada has also kind of pushed this. Canada generally backs down. It's hard being somebody's neighbor and arguing with them all the time. But this has actually turned out to be somewhat of a roadblock for cloud providers because they can't push the services around the world. And if you're gonna push a service like the cloud, I mean, that's kind of what it's meant for. And if you're not using a cloud service, and this is kind of a theme of the talk, is they're still going to get it. I mean, you may know about it. If they have to come in your house and take it, yeah, they're going to have a warrant. But at the same time, you're not going to stop them from getting it. If you can use good encryption, things like that, and they're even working on ways to make sure that you will turn over the encryption keys or sit in jail. So yes, there's some threats from this, but honestly, if they want your data, if it's hiding under your bed, they're going to get it. Compliancy. I'm speaking specifically about SOX and HIPAA in this part, just because they tend to be more similar than PCI. They're both considered compliancy standards that most of us are familiar with. I've worked in hospitals, worked for PCI ASV. SOX I haven't had as much direct contact with, but it's still something we have to deal with. As far as a compliancy, though, as far as data security, that's not really what they're intended to do. We kind of talk about them a lot like they are, but really there's not much there as far as data security, and what is there is very non-specific. I think in the HIPAA standard, there's actually a couple of sections that end with "to the best of your ability." What is that? Can you prove that? I mean, maybe ROT 13 is the best I can do. That's probably the best encryption standard I could write by myself. If I couldn't rely on libraries or something, that would be about it. SOX specifically came about because of Enron. There were a couple other fraud cases that helped it out, but that was the main push. And that's what it's meant to protect. It's meant to be forensic, so they can go back and look at financial records and say, did you commit fraud? COBIT is often referred to as the data security standard for SOX, but it's not really official. I think they just kind of leached onto that because it was the most established standard at the time. And COBIT does kind of clear up some of the stuff, but as I'll get to, a lot of these different compliances are now leaning on PCI just because it's so much clearer. As far as HIPAA, again, it's focused on patient data and the appropriate transfer of that data. There's not a whole lot there for data security. It's, can I legally turn this over to you? Do you have a right to request this? And if so, which of these standards does that fall under? There are a couple things about like not using shared accounts, things like that, but it doesn't really go very in depth at all when it comes to actual, like what I consider at least network security. HouSecCon was kind of a addition to HIPAA, and HouSecCon added a couple more computer security things, but the main focus of it was breach notification. So that if, you know, your hospital or insurance provider gets hacked, they send you a little card with a kitten and spilt milk, and they're like, oops, sorry, you lost your data. Which, I mean, it's better to be notified than not notified, but still, you're not really doing too good at that point. PCI, it differs in a lot of ways from SOX and HIPAA. One, it's not managed by the government. There are pros and cons with this. One, anything that the government does is slow. Everything requires legislation, you know, and well, I mean, I know they reaffirmed the whole "in God we trust" thing yesterday. All other problems are apparently solved. And yeah, I don't even think anybody was disputing that. But as far as SOX and HIPAA go, the good part about that being managed by the government is that they have more teeth. They can fine you pretty heavily. They've got a little more control. On the flip side of that, with PCI, it's much faster. It can adapt to technology quicker. You've got a council that kind of votes on these things and, you know, implements changes. But the downside is it's run by the credit card companies. So if they're going to fine or just refuse to work with certain companies that refuse to get compliant, that's kind of conflict of interest to a degree. And from what I've seen so far, I think that they've managed that well. But it's one of those things you kind of have to think about. As far as the cloud goes in relation to PCI, and I wanted to go in depth with this one because, like I said, the other ones really don't say a whole lot about it. There are a lot of different parts of PCI DSS that, at least in my opinion, would specifically like limit the use of certain cloud environments. You've got build a firewall router configuration, restricts connections between untrusted networks. Good luck with that. Implement a DMZ. No need to go any further on that one. That's going to be tough. Use intrusion detection. The way this is written here, I mean, it seems like, you know, this has to be a network IDS. I don't really see why a local or HIDS would be a problem here. And a lot of the cloud services are now offering that. So it's one of those things you could get into kind of the details of it with an auditor. And if any of y'all have went through an audit before, that's kind of what you're at the discretion of. None of these things are, you know, cut and dry, and it's always up to their discretion. But one of the good things, or another good thing about PCI, is that the industry can kind of change things faster. This was actually a nightmare for me personally, but the first like ASV standard required that if you're using a secured site and you're using a certificate, that the exact address of that site be listed in the cert. I mean, it'd be verbatim what's in there. Well, that drove me insane because every scan that we did came back as, you're violating this. Well, by the time, you know, a couple of years later when like the PCI DSS 2 came out, this was no longer an issue. And what had actually happened there was all the big cert providers had said, hey, we're going to start offering PCI compliant wildcard certs. And I mean, I remember the first time I saw it and I'm like, but you can't. And now they've got that changed, so that is actually okay now. And that can be good or bad. The industry can push things in really bad directions or good directions. And if they push in a bad direction, come up with an exploit to prove that that's a bad direction. As far as different types of solutions, Some companies have tried to do this in the cloud. I couldn't find a whole lot of details on the different, the really getting down the nitty gritty of how it works. So I really don't have too much of an opinion on that at this point. But I can tell you most of the infrastructures that, most of the cloud infrastructure isn't really capable of pulling off some of these things, or at least as they're currently written. And then if you talk about the Cloud Computing Association, their solution is to do your content hosting in the cloud and all your back-end processing, locally or in your own data center. I don't know why anybody would do this. I mean, usually if you're worried about scaling something, it's not the flat content. It's going to be the dynamic stuff. It's going to be the database-driven stuff. And if you're using some sort of API to talk back to it, I mean, some of that has to be hosted in the cloud. It's got to be on that web server they're talking to. So, I mean, yeah, I guess that would technically work. It would still have credit cards and memory, probably stored on the disk somewhere, log files, something like that. But this is what they're suggesting. I don't really think it'd work, but or it's not a good solution. Some of the technical side of things, and these are things that specifically you have to think of with cloud stuff. At DEF CON 17, Alex Stamos did a pretty good talk about abusing the Amazon public AMI system. And what this is Amazon has a couple different image types you can pick from. And you can also build your own, put it up there, and decide if you want to share that with others. Well, what he did was figured out that one, their rankings are basically done on just a pretty randomly assigned ID number. So he could resubmit the same image over and over again until he got a low enough number to show up in the first page. What he was also able to do was put a little callback script in there that would notify him every time someone loaded his image. Well, if you're able to run that code, you could run some other code. In fact, this was unintentional, but there was a situation where somebody had put an image in Amazon Public Images, and they had put a root SSH certificate in there. Well, if you're not using the tools to lock down SSH or any other service that you can use like that, you can just log in as root to any of them. So there's definitely some concerns there, but again, I don't really think that's a cloud problem. MySQL got hacked, their software got Trojaned, and then it's not the first time that's happened. You don't really need to be in the cloud for that to happen. There are some other things. Software is consistent. If you find a bug in one of the 26 Amazon sponsored or created AMIs, which by the way, out of that 26, at least a good 5 of them are to teach you how to use their cloud. So they're not something you'd really run in production. They're you load them up and kind of play with it for a little while before you put a real image on there. But if you found a bug in one of their default images, you could probably replay that attack across Amazon's network and take out quite a few people. Another thing is apps. They usually have either they're prepackaged in the AMI or there's an easy install. And this, especially when you're talking about cloud web hosting, those usually have just a push button, install WordPress, install Coppermine, what have you. So just because people are offering these things doesn't mean you have to use them. You can still do your just do a base Debian install and put WordPress on it, put a database on it, and you can kind of get hit by malicious software either way, or just poorly written software. So basically, there's nothing new. This is all the same stuff. It's just replayed again in a new technology. When I did the Android attack that Michael was talking about, that was not a specific phone memory corruption. It was just memory corruption. It was a use after free that we'd all seen before on computers. It was just neat because it was on a phone now. If you could write one for a calculator, that would be cool too. But As far as compliancy, yeah, there's some issues, but compliancy isn't really security. I mean, a lot of us don't do what we do because we're just dying to be compliant. Now, it's, you want to be able to protect the data. Compliancy shouldn't limit that ever. And there's some things you can do, if you follow the compliancy standards like patching and things like that, that's going to help, but that by no means makes you secure. It's like, I just hacked you. Well, no, didn't you see this? We're compliant. Privacy issues, that's like I said with the whole Patriot Act slide, this is going to happen. It's out there. How many users is Facebook up to now? I mean, people love putting data out there and really aren't happy when people find an interesting use for it. But it doesn't stop anything. It still keeps growing. Twitter keeps getting bigger, all these things. Foursquare, which, why? I need everybody to know where I am all the time. So, if you're in the cloud and, you get hacked, I mean, did you get hacked because you were in the cloud? I mean, possibly, I guess it could have been, by proxy, but there's no specific cloud attacks. There's no like cloud memory attacks or cloud CSRF or anything like that. It's the same bugs, it's just reapplied in a different environment. If we learned how to fix those in the first place, they wouldn't be a problem over here either. So the real problem is the impact of the whole thing. I mean, buffer overflow is a problem here, it's a problem here, but when this one hits, it's going to be huge. But or at least most of us here, as a small or even a larger business, we're not driving the Exxon Valdez. We're driving the car and slamming whiskey. As far as what our risk is, it's really not that different than if you were hosting it in a data center, or even in-house. If you're hosting something in a data center and you get hacked and somebody gets all your data, how's that much different than if you're hosting everything in EC2, somebody hacks it and gets all your data? There is one difference that I see I'm going to go into, but for the most part, I mean, you're kind of dealing with the same stuff, the same types of attacks, the same poorly written code, things like that. So just like anytime you want to add a new system to your network, if the marketing guy comes over and says, hey, we need to add a new blog, pop open a hole in the firewall and give me a server. That's something you can't just do that. You have to figure out how this is going to impact your whole network. You have to make sure that system is secured. And I kind of view the cloud the same way. If you're basically adding software, and kind of like where it differs is it's kind of like the one ring to control them all kind of thing. If you find a hole in Amazon services, like Amazon's hypervisor, provisioning services, I mean, well, you've basically got everything. You've got more data than you would know what to deal with. So that's really the only difference I see is, you're adding these layers that make it, oh, you're kidding me, that didn't load. What? Okay, give me 1 sec. This is too funny to miss. Lame. Okay, I'll just load up something else. Give me a second. There we go. Okay. Sorry for the delay. Technical difficulties. Probably the cloud, yes. You are correct, sir. Oh well. Okay, we'll just skip that. But essentially, I don't know if y'all know the comic strip meme from Inception, where he's doing the reverse Inception. But basically, it's like, you should try using my cloud service. And the guy says back, well, maybe you should try sanitizing input. He just looks back at him. Lame. Okay. So whenever you add multiple layers or add a layer, especially on top of everything else, you've kind of got a problem. You've you've added another section, another layer that can have security vulnerabilities. And like I said, nothing special, just the same old stuff. But you don't control that. You can't force that to be patched. A lot of times, you can't really audit it. So unless you're like, the government or a humongous company, they might let you do it. So you have to think about what happens now. You've maybe got a hole or two in your web application that you're aware of, haven't patched it. So maybe your provider has the same thing, your cloud provider. And if you're dealing with a reseller at that point, now you've got possibly vulnerable web application talking to a possibly vulnerable API, and then above, and this is above what you're currently working with all your in-house stuff, your web applications, your data storage. All web applications have flaws. I don't think I've ever done any type of assessment or pen test on a web application where I didn't find at least something. It's not always something like as epic as SQL injection or command injection, but there's always something there, something that discloses something about the back end, things like that. But it's very likely that you're going to have, and actually I'll show y'all later, it is incredibly likely that your cloud provider has the same problems you do. And if they're working through a reseller, the reseller's code is usually a little buggier. So now you've kind of given the keys of the kingdom to something you don't control. As far as infrastructure, this is pretty simple. You're slapping another web application for management on top of it. But the difference in this one and some of the other ones is this can control everything. It can take out everything you have, could alter it in different ways. If you're using a reseller through this, which this is getting incredibly common. I bumped into this quite a few times while testing services. And not all of them say, hey, we're reselling this. When I went and looked back later after I'd had an issue with that, I did realize the only clue was that they had cut and paste the frequently asked questions off of the site they were reselling from. So if you're using more like SaaS or framework as a service, you're not really putting another layer on top. You're just kind of pushing your stuff out of your protected layer and under someone else's who you're going to trust to then hopefully at least protect it as well as you were. But the problem with a lot of these, in particular like Salesforce, things like, I don't know if you want to call Facebook Cloud, but they have pretty similar setup, is that they allow a lot of customization. They allow applications to be built. How do you let somebody edit code in your web application and keep it secure? I know that they've come up with some really neat tricks for doing that, but when there's a will, there's a way. Somebody can always figure out a way. It wasn't even that long ago. Like, how long has Facebook had their FBML and the Facebook app service? It's been quite a while. Well, as early as I think like 5 months ago, 4 months ago, they had found basically with certain web applications using the FBML, which is actually submitted as a parameter to a GET or POST request, we'll load the whole thing. And FBML isn't really that different than HTML at all. And you can load malicious data that way, or load malicious sites, cross-site request forgery attacks, cross-site scripting. And that's one of the reasons things like Twitter will never be as insecure as Facebook, because Twitter doesn't do a whole lot. Facebook has so many different options you can work with. And with all that stuff, you end up creating more holes. So basically, what makes the cloud a security risk? And it's really the same stuff. It's the same type of attacks that we're already fully aware of. SQL injection attacks, memory corruption attacks. If we figured out how to solve those, then they wouldn't be a problem in the cloud either. We don't really seem to learn from our mistakes. I mean, how long has actually, we were looking this up last night. CSRF has been around since 1988. I think I was on a Trash 80 at that time. So I mean, that's kind of a while. And I think one of the big problems with that is we keep trying to set up the cloud like it was our own infrastructure. We keep trying to, like, oh, I want a DMZ, I want all this stuff segregated. Well, that's not really how it works, at least not right now. So we either need to figure out a way to make it work that way, or possibly even better, figure out a way to adapt. I mean, that's what we're supposed to do as, security people. We're supposed to take what we're given, figure out how to do something else with it, something more creative that works out better than the original idea. As I said, we keep repeating the same mistakes. If we worked more on figuring out how to code securely and put in helpers there. I mean, when you're writing applications, that's not your main focus. You're trying to make it work, and you're usually on a deadline. So building tools that assist in protecting the source code or making sure that it's secure is very helpful. And that's really what we need, because I don't think anybody has time to sit down and poke through every single possible function. If you're planning on using cloud services, know what you're getting into. Know how the service works. Play with it. See if you can twist it in some way it's not supposed to, or to make it do something it's not supposed to do. They may not like it, but as long as you don't go breaking into anything, it shouldn't really be a problem. A little bit of scanning here and there, and honestly, most CSRF or cross-site scripting vulnerabilities can be assessed without ever putting anything malicious in there. My favorite for cross-site scripting is I've got a little clown face, like just out of meta characters, and then I just look at the source code. Which ones got through? Could any of these break it? And then it's not malicious, nor it's not going to pick it up. It's a good, safe way to test things, because the worst thing that can happen is you actually put in some type of injection string and realize, oh, that just hit everybody. And the Sammy worm, that's basically what that guy did. He was playing with it. He was testing different things, and then it got out of hand. And once the code was out of his hands and showing up on other people's pages, he had no control at that point except for just watching the ship go down. Happened recently on Reddit, and what was cool about that one is the guy was posting in Reddit programming, so you got to see kind of the progression, because he was working on it with multiple people. Well, then they got it to work, and next thing you know, the same statement's being posted in every single comment on Reddit. They were a little cooler about it than MySpace was. The guy apologized. They said they were cool with it. They fixed the code. But if we do all this stuff, then hopefully one day we can have a little less insecure cloud. So thank you very much. Does anybody have any questions or comments? All right. Oh, go ahead.
In an earlier talk, you mentioned that in the Amazon in particular, every machine has two domain names you don't think about.
Yes.
And that seems like a specific cloud attack, specifically the fact that you're in the cloud.
I agree. I agree, but and I actually tested this to death. I scanned a bunch of port 80s on Amazon's cloud network, and just basically went to every one of them using the domain, the EC2 kind of IP address resolved domain, and just checked out the ones that would stay. Like if you browse to it, would it overwrite it with a domain name, or would it leave the name? And that worked in some places. The downside of that is you have to crunch down both the domains. So you have to run JavaScript so you'd have to find a cross-site scripting hole in that site as well that would allow you to set the domain to just amazonaws.com, and then you could do that on your own cloud-hosted site. And then you could do full-on communication between using frames. But since that still relies on another cross-site scripting vulnerability, you know, it still needs that problem, so, or still has that problem. So keep going. Oh, okay. I always go too long. All right. Well, thank you very much. You know, I'll be around, so if anybody has any questions, let me know.